is something really good, but it's hard to explain spatial reasoning. It's something you just have to kind of develop through experience. So I don't want you to be afraid of today's stuff. Just be willing and open-minded, and try to hear my description of the different shapes that we're going to look at, help you perceive their shape. So we're looking at something called composite volume. So we've talked about the volume of prisms, specifically rectangular prisms, and we know how to calculate that, length times width times height, right? But it kind of looks today like some prisms are either stacked on top of each other, or there's a prism with a part of it removed. You see that one? So we're going to be learning how to manage finding volume of an imperfect space, because really in reality, in the real world, you hardly ever have perfect circumstances in a perfect space. A room is hardly ever a perfect prism. So you might have like a cutout for your closet, or maybe, you know, you have a certain amount of space on a shelf that has some constraints like this. So we are going to get to understand, well, what do we do in these circumstances? So the little section up above talks about some cabinetry. I'm on workbook 277. And if you wanted to find the total volume of these two prisms, you kind of call one of them shape A and one of them shape B. And the total volume would be the volume of shape A plus the volume of shape B put together. Would you agree with that? Yeah.
Yes.
So we're just kind of looking at how can we decompose the total shape, solve each piece separately, and then do what we need to do, okay, to find the total volume. So let me scroll down. My plan for the day is to do these four with you, and at probably number 2, and then let you do 1, 3, and 4 on your own. And it might be hard and it might not be perfect, and that's okay. We're just gaining some experience and exposure to finding composite volume. So these are the top 8 that we're going to work on today, okay? And then you don't have a Zoom at all for me tomorrow. We're a little bit ahead of the rest of the class. They're going to continue to do scavenger hunt at school tomorrow. So you don't have to do that, obviously. You can continue maybe doing some scavenger hunt items on your own at home. Or you can take the day off. It's up to you. But let's get through this composite volume business. And I don't want to start with number 1. I don't like number 1. Well, I do, but not first. I don't like it first. I like number 2 first, and then we're going to go to number 4 next. Why do you think I'm picking number 2 first? What do you think? Why does it look a little easier than the rest? Why does it look a little easier? Doesn't it kind of just look like maybe a textbook with a cube sitting on top of
I was
it?
gonna say that.
It's pretty, easy to perceive. Like I can see the prism on the bottom. I can see all of its dimensions. I can see the prism on the top, and the directions say, hey, that guy's a perfect cube. So I know all the dimensions of that one too. So this one looks like it will be easy to kind of combine their volumes. So let's try that one first. Okay, remember I suggested that we label each shape. So we're going to call this guy shape A, and we'll call this guy shape B. And maybe you can write over here on the right-hand side of that problem, but the total volume of this shape will be A and B put together. So the total volume of this yellow prism set will be A and B put together. Do we agree with that? What do you guys think about that?
Okay.
Feel free to unmute and ask a question anytime. You guys don't have to raise your hand, because really I'm not looking at the screen that shows your faces. I'm looking at the screen that shows the workbook page and all my annotation tools. So I can't tell, I pop back to your faces every now and then. But I can't tell if you're raising your hand unless, you know, you speak up, okay?
Okay. I actually have a question.
Sure.
Does it always have to be A and B, or
You can label it hearts and stars if you want, or you can color like one of them green and one of them blue. So it doesn't have to, this is just a labeling technique that's common, is to label it with letters. You do what you need to do. I had someone draw flowers and hearts. So shape A was a flower, shape B was a heart. Whatever you need to do to decompose it in a way that makes sense to you, fine by me.
Could there be 3 shapes?
For this one, there is not. But if you sneak ahead to 278, look at 278. Which one has 3 prisms put together?
Number 4.
Number 4, got it. Yeah, number 4. So yeah, there can be as many shapes as you can perceive, right? So things are complex, and if you have to break it down into 5 different prisms, then you do. But for 5th grade, 2 or 3 is the max. There are some situations in 6th grade you'll see where you can split it in whatever way makes sense to you. So you might end up with 6 parts, you might end up with 8 parts, right? So yes, there's multiple ways to go about solving a problem typically. All right, let's find the volume of shape A. Volume of shape A is going to, here, we'll put an A in front of it. Is going to be length times width times height, right? What is the length times the width times the height of shape A? So it's a perfect cube. So I do know something about its length, its width, its height are all going to be what?
The same.
They're all going to be the same, and they are all going to be congruent. It says this length is 1, so I know the length is 1 times the width is 1 times the height is 1. So what would the total volume of shape A be?
1.
1 foot cubed. You got it. 1 foot cubed. And what is the volume of shape B? It's still length times width times height because it's a prism. But this time, what's the length, the width, and the height of that shape? What's the length, the width, the height? What do you see?
2 times 8
and 4.
Yeah, and the order doesn't matter too much, guys, right? Because multiplication is commutative. And 2 times 8 times 4, if I rearrange them to make it more fast fact friendly, could get 2 times 4 is 8, and then 8 times 8, 64. You got it. As much as we can resist the urge to grab the calculator, the better. It forces you into making some deeper connections here. Okay, so we know shape A is 1 foot cubed and shape B is 64 feet cubed. So what would the total volume be? 1 and 64. What would that be altogether, everybody?
165 foot cube.
Just 65 feet cubed. You got it. How you doing, Ryan? You there? Earth to Ryan. All right, buddy.
Yes.
Okay, how's it going? Are you understanding what we're saying?
Yes, but well, my Wi-Fi is kind of bad here, and I'm not really getting everything.
Okay. Well, it is being recorded, okay? So if you need to like scoot back to some of our examples, you can do that later, okay?
Okay.
If you're home because you don't feel well, take it easy. This doesn't have to get done today. All right? So
okay.
you have a couple of days that tomorrow we're just doing like the scavenger hunt thing at school. And if you don't come to school, that's not a problem. You can just do this workbook page, okay? All right.
Okay.
All right, take it easy. Here, we're gonna do number 4 next, right? Number 4 looks a little bit like number 2, just different shaped prisms. It reminds me of like a cereal box with like maybe some graham crackers sitting in front of it in the pantry. There's 2 different shaped prisms that are stacked up in the same place with each other. So I do want to label them shape A and shape B again. Okay, and now I don't care which way you label them. I'm going to do this. So the total volume here is going to be A and B put together again. Agreed? All right, so volume of shape A, length times width times height. Now I can see the height. I can see the length here, but the width covers this entire distance that is both prisms put together. How can I tell what just this part is worth? Are there any other measurements on this figure that will help me understand just the length that is from here to here or here to here?
Well, there's a 12.
To
Yeah,
here.
there's a 12 and 16.
Yeah, so the 12 goes from the top of this shape to the bottom of it. It's the height of shape A. And I can tell the width of shape A because 18 is congruent to this spot, is congruent to this spot. So I know this is 18 along the bottom as well. But that still doesn't help me know how deep shape A is. I do have this depth information right here for shape B. And if that's 9, how can I figure out this information right here, knowing that their total depth is 16? So A and B put together has a depth of 16. Shape B is 9 by itself. So what would shape A have to be by itself? 9 and what together would make 16?
7.
7? Yeah. So 7 from shape A, 9 from shape B. If you push those two distances together, do you get 16 altogether?
Mm-hmm.
You do. So now we've found, just by using logic here, what the depth, the length, and the width of shape A are. So that's going to be our length times our width times our height, or length, width, depth. It's up to you how you like to label those dimensions. Either way, we're grabbing an 18, a 12, and a 7. I'm going to use a calculator here to save on time. You're more than welcome to use a calculator. Well, if it doesn't draw all over the screen. Let's see.
There's more.
Yeah,
I got the answer. Do I just say it or?
sure.
I got 1,512.
Oh, that's for just shape A or total?
For shape A.
Okay, for shape A, I got something a little bit different. I did 18 times 12, and then I did times 7, and I only got 1,512.
Yeah, that's what I got.
Oh, I
1,000.
think you said 4,000. I'm sorry. So I got 1,500. What did you say? 1,500.
And 12.
Thank you.
Mhm.
All right, and that's not feet, it's inches. Inches cubed. Okay, what about shape B? What's the length? What's the width? What's the height? So this one's gonna be bigger, right? Length, width, height. Do we see all of those dimensions there?
Yes.
All right, let's multiply that. 30 times 18. 30 times 18 times 9. Did we get 4,860?
Yes.
So 4,860 inches cubed. Well done. So the
I don't know why you're
total.
multiplying so fast, because like I'm still multiplying this problem.
Oh, Michael, we're using a calculator, hon.
Oh.
So yeah, that's why. You're welcome to, go after this with traditional calculations. But if you just want to zip through it with a calculator, I'm totally fine with that. Our focus today is composite volume, not, multiplying double-digit numbers. But so Esther, when you combine those volumes, what did you get all together?
So 4,000 4,860 plus
Mm-hmm.
1,512 to 7, 13, 6,000, 6,372.
Okay. Inches cubed. Sorry if we didn't make that clear, Michael. You're probably like, how in the world are they calculating so fast? All right, good job. So how's number 3 different?
It has a shape inside.
Okay,
There's
Is
a shape. There's a part of the shape missing.
okay, missing was kind of what the word I was looking for. It's removed from the middle. So if something is missing or removed, what operation would we do between those two prisms? Would adding be what we have to do, or maybe something different? How would we go about finding just the volume of the purple space, not the empty space that is in the middle of it? What could we do? So adding is putting together of shapes, but how would I remove this part from the total prism? How would I remove it? What
You would
operation?
subtract.
Yeah, let's subtract, right? So we have shape A is the big boy, and then shape B over here is the little guy. If I know the total volume of the purple prism and then remove the invisible place in the middle, I can find the remaining prism piece that wraps around it, okay? So in this circumstance, total volume is going to be shape A minus shape B. Now look ahead to your homework. Are there any that maybe have this same feel to it? 1, 2, 3, or 4? What do you think?
Possibly 3.
Yeah, I think so. It looks like almost a slice of cake was taken out of maybe a large sheet cake or something like that. Someone took a piece and snuck off with it. So yeah, that looks like a takeaway type of problem too. All right. How can we find the volume of each of these? They're both prisms, so we still do length times width times height, but at the end, instead of adding, we're going to subtract their volumes, okay? So what is the volume of shape A? All right, let's see. We've got our length is 5. Our width is 5. Our height is 3. Okay, so length times width times height. And what do we get for that? 75?
Yeah, 75.
Good. And shape B, I kind of covered mine up with the line here, but what do we have? We have 1 times 1 times 3. What's 1 times 1 times 3? Just 3.
3.
So
Yeah.
total volume is going to be A, which is 75, minus B, which is
72.
just 3. So just 72. Yeah, 72 meters to the 3rd power. We're still talking about volume, 3 dimensions. Hey, that one was actually not too bad, right?
Mm.
But we could see the boundaries of that whole invisible shape. Number 1, not so much. We can't see the boundaries of that invisible shape. We kind of have to perceive it or draw it. And what I'm going to do is I'm going to actually zoom in on this problem a little bit more so that you can maybe draw with me the invisible part that is being removed. And we'll draw some dotted lines to help us perceive that space, okay? So let me see if I can zoom in a little bit more. All right, that looks a little better. Maybe a little more, come on. Nope, that's as big as it will get. And then I'm gonna encourage you to just use your pencil, and you see this line right here? We're gonna continue it invisibly. So we're just gonna draw some dots. Just keep on going, keep on going. And where those dots meet, then you're gonna drag it down. We're kind of creating the missing piece of this prism. You can see the part that's removed a little bit when you, oh, Hello. You can see the part that's removed a little bit when you put these dotted lines. I keep using my eraser instead of my pen. So you can see like a corner was chunked off of this big prism, right?
Yes.
So again, we can say that the total volume will be shape A minus shape B, because shape A is the orange part and shape B is this invisible place right here. That's shape B that we're removing. We're going to remove it, and removing means subtract.
Mhm.
All right. Let's see what dimensions we know. Do we know all the dimensions for shape A? Let's see, length, width, and height. Do you see a measurement for each? Okay, here's one dimension. We've got the length, we got 6. And then come down the corner here. Do we know the length of this piece right here?
No.
Well, I don't see anything written here. So let me go to a congruent face, which would be here. I don't see anything written there. But I do see 4 is this part of it. How long is this little part that's invisible?
1.
1, yeah, because the congruent faces or edges that kind of define this cutout, this is 1, and therefore this is 1, and therefore this is 1, right? And therefore this is 1. All those edges have to be congruent. So if I know that this is 1 over here and this is 4, I know their total length from here to here is going to be 5 centimeters. And therefore from here to here is 5 centimeters. And from here to here is 5 centimeters. So we can use those congruency rules for that. So good, that is the next dimension. We've got a 6 times 5, and what's the height? That one's easy to see. What's 6 times 5 times, what's that last dimension? Of
5.
height. Yep, another 5. Good. So 6 times 5 times 5. 150.
Yeah.
And 50, yeah, because 6 times 5 is 30. And then I can kind of use it as a fast fact. 3 times 5.
Poor God. Bad kid, poor kid, poor God.
All right. Shape B now, guys. This is the hard one to perceive because it's invisible. But let's see, can we get a length, a width, a height of that space? So we know that the total length of shape A is 6, and this little guy out in front is 2. So what would the length of the other part out in front be that connects with it? 2 and what together would make 6?
3.
That would be 5. So 2 and 4. This one would have to be 4. 2 and 4 would make 6. So this length right here has to be 4. All right, we're going to use 4 for the length. And we already know 1 was the width. And then what is the height of this shape? We already have that information too. Can you find it? What's the height of this shape? How tall is it?
It is also 5.
It's also 5, yeah, because this length is 5, this length is 5, this length is 5, this length is 5. They're all 5. So 4 times 1 times 5, 20. We're going to subtract those 2 volumes. Hey, I'm on a Zoom. Subtract those 2 volumes, 150 minus 20. What do we get?
130
centimeters cubed. Oh my goodness. This is hard stuff, isn't it? Especially I save it for the end of the year when our brains are fried and we're ready for a break. That was mean of me. Okay. I'm going to do one more with you before you go. It's one of your homework problems, and then you will have a couple more to do for me on your own. Nope, Come on, Mr. Penn. There we go. Uh-oh, it's being slow. Am I cutting in and out, guys?
No.
No.
Do number 1, and you're gonna do number 3, and you're gonna try number 4. And then I'm gonna do number 2 with you right now. Okay? So
Okay.
number 2 is on 278, and it looks pretty good to say total volume is gonna be A and B put together, right?
Mm-hmm.
Now, I'm noticing some differences though about how the dimensions are written on here. All of these are centimeters, 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 centimeters. But if I look at this shape, I've got inches, inches squared, and feet. All these different units on one kind of figure is confusing because I have to only calculate a volume using the same units. So I see mostly inches, right? So this guy, I'm gonna wanna change it to inches so that it can be compatible with my other units. How much inches would be in, how many inches would be in 1 foot? How many inches? How many inches are in 1 foot, you guys? Do you know?
Oh, so you mean from back then when we were doing the converting?
Yeah, so just in 1 foot, there's 12 inches. So actually, I just want you to cross this out and put 12 inches. Now that we have inches, this becomes an easier problem. Okay? They have told us that the area of this front face is 3 inches squared. So the area of it is 3 inches squared. If I just multiply 3 inches squared by its depth, which is 8, then I know the volume. So the volume of shape A is simply 8 times 3 inches squared. So 8 times 3, what would 8 times 3 be?
24.
24, good. And shape B, again, I'm told the front face, I'm told the area of this front face. So I just have to multiply it times the depth. What is the depth of shape B? We changed it to inches. So we've got 8 times, what's the depth?
12.
12, 8 times 12, good job. 8 times 12, it happens to be,
96.
thank you. All right, now this is no sweat. We can put A and B together, and what do we get for our total volume?
Um,
100 and
110.
110. We get 110, or is it 112 or 120?
I think it's 120.
It's 120 because you have to regroup. So 6 and 4 is 10. And then I would regroup this to be a 10. 10 plus 2, that would be 20. Okay.
Oh, okay.
120. And that's going to be in inches. Volume is to the 3rd power. You don't have anything like that on the other 3 problems you're doing. Everybody's in the same units. Everybody can see like perceived space and distance. You're good. So let's just talk through shape A, or shape number 1 here, and then you can go and figure it out on your own. What would the total volume of this figure be? How many prisms do we have here at play?
2.
2. Okay, so we could call this one shape A or shape B. It's up to you. But the total volume would be A and B put together, adding them. Now, number 3 kind of reminds me of that slice of cake one, right? Where you have this section that is being removed, right? So total volume here, try out the total purple part before the cutout, and then take away that invisible cutout section. So try taking it away. And then what do we think about shape 4? What would the total volume be? We've got an A piece, right? A B piece and a C piece. Here, I'll put the label there. So A, B, and C put together are going to represent our total volume of that shape, okay? Good luck with these. You have a couple days to work them through. So if you need to walk away and take a break, that's fine. And you know what? On Friday, I'll post the answer key to these so that you can compare what you did and your calculations alongside. Okay?
Okay.
Sound good?
I have a question on number 3.
Sure.
So some of the meter distances, they have a decimal point. So does that mean that we multiply by decimal?
Yeah. And so when you type that into a calculator, you just press the decimal point button. But remember, if you're multiplying with decimals, paper, pencil, however many decimal zones are in the problem or how many are in the answer. So you
Okay.
just push that decimal point in as many times as you need. Okay.
Okay.
All right, guys. Hey, great job sticking with this stuff. It was a tough topic. Just a couple more days of instruction left, really. I mean, we've got about 10 school days left with some fun stuff sprinkled between. So hang in there. You're doing great. You have a couple days for this, okay?
Okay.
Bye.
Bye, Miss Moore.